Hello students. So now we are again going to solve one more problem, and that is from mechanics, and it is basically on conservation of momentum and energy. It's a quite simple problem, but in this problem when you are going to solve the equation, you have to be little bit conscious. What is so let me first explain this problem. So there is one spring mass system. Is it rigid support? The spring constant is K. This is ideal spring, and another block of mass 2m is moving with energy E. So it is moving with energy E. So there is, and this is just a frictionless surface, so there is not any problem. So obviously it is moving with constant momentum also. And once it is moving with the constant momentum and constant energy, so every energy, the total energy is nothing but the kinetic energy. So it is moving towards left, and finally it collide with the small mass m, and both move together. And after then both is moving together, and we have to calculate what will be maximum compression of this particular spring. So it's a quite simple problem. So first, let me go for this problem. I can say that my kinetic energy for mass 2m is 2m v square is equal to E. So I can get the value of mv square, and which is E. So this is one variable I have to use after during the calculation. So obviously there is not any external force. Whatever the forces will be act in the system is just internal. If I will take the whole mass 2m and the spring as a combined system, so we have conservation of momentum first. So initial momentum is 2m into v, and this is my initial momentum. The final momentum is basically 2m plus m into v1. So we can get the value of v1, that is just after collision the combined system have velocity v1. So v1 is equal to basically 2 upon 3v, and after then we can use the conservation of energy, because we have, and we have to use conservation of energy from after collision and up to maximum compression. So let us assume that A is the maximum compression. So we have half K A square, and this will equivalent to half the combined mass is 3m into v1 square. So we have to write A in term of V or E. Mainly we have to write in term of basically E. So this half K is not needed here. So we have K A square is equal to 3m, and I can put V1 is equal to 2 upon 3 V square. So this value is mv square, that is 4 mv square upon 3, and I can put mv square is equal to E. So this is the thing we have to manage in our mind, that I have to give the answer in term of E and K. So I have to remove this particular thing. So I can write Ka square is equal to 4 E upon 3. So the value of A is nothing. This is given by 4E upon 3K. So this will be the answer. And this is quite simple, but maybe sometime when you are going to solve this problem, maybe you will trapped into the calculation if you are solving each and everything in term of V and something. So initially what you have to do, you have to write mv square is equal to E, and then you can easily solve it. Another way is that you can initially take P and E as your variable, and then also you can solve it. But I think this is the simplest way we can solve about this problem. Okay, thank you.